Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Previously, I would like to thank the permit of the 5th Borobudur International Symposium for giving me the opportunity to present my paper with the title Classification to Predict Credit Card Application Acceptance Using Support Vector Machine. Please introduce, my name is Aswan Muqtadir as presenter, and my college friend Andi Adi Suryanto, Amaluddin Arifia, and Fitroh Amaluddin from Faculty of Engineering, Department of Informatic Engineering, University of PGRI Ronggolawe, Tuban, East Java. I divided this presentation into 4 parts. Part 1 is research background, and part 2 its method, part 3 research result, part 4 is conclusion. Part 1 research background. 1. The credit card granting process must include submission and analysis of the customer profile. Customer profile analysis can be determined based on many factors such as saving on, transfer, or cash flow from customer account, and income from customer credit application. By using existing attribute and criteria to classify client data applying for loan, the desired result will be achieved and minimize the risk of the fraud to credit card base. The method we applying is using support vector machine, starting from data analysis, which consists of data exploration, data visualization, correlation analysis, and then last feature selection. After feature selection, we'll be go to processing, then pre-processing data, start with encoding variable, and then data normalization. After data normalization with splitting data, and after data splitting we'll be calculating with SVM model algorithm with start initialization, then has been trained, its result is no, then train it model and go to model evaluation, and if result is yes, we'll go to model evaluation with 4 type of kernel, then result classification accuracy and result of confusion metric. Before starting, the data processing library or library to be used must be imported first. After importing the library, the next step is to import data. There are 2 data that will be imported, like figure 1 is application record, and like figure 2 is credit card. In study using tool Google Collaboratory, and the programming language used is Python. This table contains 17 data features that are relevant for the analysis to be performed. This feature will form the basis for the development of predictive model that use support vector machine method to classify debit card dataset results. The next step is to handle datasets and removing duplicates like figure 1, merging data in figure 2, removing missing value in figure 3, and renaming feature. The main objective of EDA are to identify structure in the data, find interesting pattern, and identify outliers that can help in decision making. Exploratory data analysis can help reveal information that is not visible at a glance and guide the direction of further analysis. For example, property asset can be considered in the approval of credit card application. Therefore, it is necessary to know how many clients have asset in the form of property or building as additional information. After having the next data information, we need to measure correlation. Correlation is useful for identifying and measuring relationship between variables. One way to describe correlation is by visualization. In data analysis, visualization is why represented information from data using graph or plot. Visualization on correlation can show relationship between variables in data. Part 3 is research results, training and testing. Before starting the calculation, the data needs to be divided into training data and testing data. In the credit card classification, the testing data used was 20% or 527 data from total of 25 and 135 data. The first calculation is carried out with linear kernel with use parameter C. From the calculation, it is found that the accuracy of the model is 96.3%. The result of the confusion metric with precision are 0.974 and recall is 0.988 and F1 score is 0.981. The second calculation is done with the polynomial kernel. With use the polynomial degree parameter, from the calculation it is found that the accuracy of the model is 98.1%. The result of the confusion metric with a precision of 0.9809 and recall of 1.0 and F1 score of 0.990. Like figure 1, its accuracy score is 0.9981. That result accuracy of model is 98.1% with polynomial kernel. Furthermore, the calculation is carried out with the RBF or Gaussian kernel. With use the gamma parameter, from the calculation it is found that the accuracy of the model is 97.2%. The result of the confusion metric with a precision of 0.980 and recall of 1.0 and F1 score is 0.990. And the last kernel is sigmoid, a calculation carried out using alpha and C parameter. From the calculation, it is found that the accuracy of the model is 96.3%, like figure side left. That accuracy score is 0.9973. Its mean confusion metric result with precision of 0.982 and recall is 0.985 and F1 score 0.983. Is conclusion. Based on the result of the evaluation of the support vector machine classification model using 4 types of kernel, it was found that the polynomial kernel is the kernel with the highest accuracy. However, the highest percentage of precision and recall is obtained from the sigmoid kernel. Complete accuracy comparison results can be seen in the following table. Kernel linear with accuracy 66.3%, precision 0.974, and recall 0.98h. Kernel polynomial 98% with precision 0.9h1, recall 1.0. And RBF Gaussian kernel 97.2% with precision 0.9h1 and recall 1.0. Last kernel sigmoid with accuracy 97.25% and precision 0.9h2 and recall 0.9h5. Thus ending my presentation, I would like to thank you. Assalamualaikum warahmatullahi wabarakatuh.